It's go time! SpaceX gets the first license for Starship's 7th flight. How long till launch? Ship 34 completes its stacking. What's left to do? Starship may be getting a new heat shield, and it is metal. And Stoke Space shows off their latest design for their fully reusable Nova rocket. Can it compete with Starship? My name is Felix. Welcome to What About It? Let's dive right in. Starship updates. Welcome to Starbase. While the rest of us here in the States were recovering from a holiday filled with food and family feuds, this spaceport was already back to work building the world's most advanced rocket. Change is the name of the game right now, as SpaceX is out with the old and in with the brand new Block 2. Ship 26 finished scrapping just before the holidays, and with it gone, the high bay, which was used to scrap the test vehicle, is empty and ready for use yet again. Unfortunately though, the high bay uses seem numbered. Until recently, the only real task left was upgrading the heat shields of older ships. With all the Block 1s gone and the Block 2s already having an upgraded heat shield, it may just not be needed anymore. Although according to a recent update from Musk, there may be one more major upgrade to the heat shield on the way. After processing all the information they gathered from Flight 6, Musk shared that an actively cooled metallic heat shield is back on the table as a possibility. But what does that mean, and why might this sound familiar to you if you're a true expert and you've followed the Starship program for a long time? Well, for those who haven't been following Starship from the very beginning, this may come as a surprise, but this was actually on the list at some point. This was originally planned for Starship in the early days. Essentially, a second thin layer of metal is placed on the outside of the hull, and then a small amount of cryogenic propellant flows between these layers to absorb heat. There would also be the option of adding countless small vents to this top layer to allow some of the gas to escape and form a film that provides even more protection. And while you may think this is either sounding like a novel or risky solution, it is nothing new. In fact, this is actually the primary form of cooling for rocket engines. Most modern rocket nozzles are made of tubes through which propellant flows before entering the combustion chamber. This prevents the nozzle from melting at temperatures even greater than those of re-entry. The temperature inside a rocket nozzle often exceeds the heat of a LEO re-entry by a factor of 2, and yet it's still not melting. Film cooling, as it's called, is also often used in tandem. However, this is typically provided by pre-burner exhaust, which is pumped in near the throat of the nozzle, such as on the Saturn V's F1 engines. Very powerful. The concept is not that far off from the deluge system you'll find on the current Starship launch pads. Wait, what? There's even a company actively developing a vehicle that will use this technique to recover its second stage, but we'll talk more about them later. SpaceX eventually abandoned this concept as they realized the idea both added complexity and increased the ship's weight. The fact that they would have needed to add complexity to the hull construction and use some of the rocket's propellant to keep it cool meant the passive heat tiles, which are now being used, were seen as a better option at the time. Since then, Musk has questioned whether this actually saved them weight or was the right call, and it appears that they are now at least considering reversing this decision. He initially mentioned that this form of cooling would still be used on Starship. Their plan was to use the technique in specific areas such as the flap hinges, so they may revisit using it only in those areas. In its current form, Starship has had countless issues with its heat shield. Tiles breaking, flap hinges melting, and last but not least, tiles falling off. Combined, all those are indicators that SpaceX needs to either fix the existing tile approach or move on to another solution. It may be a long time before we see this new heat shield applied to a new prototype, if at all. SpaceX likely hasn't clearly decided if it's worth changing yet. What do you think? Does SpaceX need to change the heat shield approach, or will they discover the magic tile that does it all? Let me know your opinion in the comments. The heat shield decision will be in the future, which means it shouldn't hold up the next flight, which is racing towards its launch date early next month. As of now, both Ship 33 and Booster 14 have completed their initial cryogenic proof tests, which means static fires are next on the list. Haha, yes! That's why we were keeping an eye out for any activity, and on the 2nd we saw a pair of self-propelled modular transporters, or SPMTs, rolling to Massey's. We can only think of a few reasons these might be headed to Massey's, but the most likely one is to pick up the crap static fire stand needed to move prototypes to the test site. We're now just over a month from the current launch date of Flight 7, January 11th is the day. With that date fast approaching, SpaceX still has a few things to check off their list, including static firing Ship 33 to ensure the engines are correctly installed. This should happen any day now. We'll watch out for any road closures and keep all of you up to date. There's something you can help us with as well. We looked into our channel metrics and there are over 2 million returning monthly viewers who have not subscribed yet. Help us improve the channel even further by double checking that you've hit that subscribe button so you don't miss our updates. And while you're at it, give us a like and become a wise supporter. Why? Because you'll gain access to a massive amount of extra content. With it, you get access to daily new Starbase photo galleries, including all those we've posted so far. Satellite, aerial, and ground photos, more than 400 posts in the past 2 years alone, with up to 7 picture galleries per week, insights, chats with me, you name it. Thank you so much, you rock. Now back to Starship. Interestingly, while we were looking out for a road closure to move the ship, the booster also decided to get in on the action as its transport stand was rolled over in front of the mega bay. From here, the booster was placed onto the stand and should be rolling to the pad ahead of its static fire any day now if it hasn't already happened. Please let it happen. And Flight 7's hardware isn't the only thing seeing some action lately. Ship 34 has arguably been moving even faster as it completed stacking just over 2 weeks ago on November 18th. This ship is for Flight 8, so if everything works out, this might be the first one to attempt a catch at the launch site. So it's definitely worth a closer look. With stacking out of the way, many of the smaller components still need to be added and completed, which is exactly what we saw happen over the following weeks. Most of the recent work culminated on December 2nd and teams moved and installed the ship's raceways. The raceways? This raceway transfers electricity and data up and down the ship's hull, from its batteries and flight computers near the payload bay down to the engines. Oh, that raceway. Block 2 has 2 redundant raceways and both seem to have been installed. The ship was then lifted off the welding turntable where starships are stacked and temporarily moved to the middle work stand before finally being moved over to the front left stand in Mega Bay 2. This last step is to finish work and clear up space on the turntable for the next ship in line, mass production. These ships go through different positions like a car in a production plant. Fascinating to watch. We'll likely see Ship 35 begin work soon, as the nose cone appears to be around the same stage that Ship 34's was when it was first rolled out, minus the forward flaps. So now let's talk about the elephant in the room. These new Block 2 ships will need a launch pad, right? As for now, both are still out of commission though. So when's that changing? Starting with Pad B, we've seen some work near the housing at the base of the tower, possibly some final prep work ahead of chopstick installation. Most of the hardware needed to operate the chopsticks is already on site. The massive LR11000 crane is also raised and ready, awaiting the chopsticks to be rolled. Hopefully we won't need to wait much longer. Hopefully. However, most of the work currently underway appears to be on the ground around the pad and tower. The terrain has been graded quite a bit recently, with massive mounds of dirt being moved to make way for these new underground pipes. Some of the infrastructure for this tank farm will go where the Starhopper used to be. However, it has since been moved to a much safer location and appears to have finished its refurbishment process. So all good with Hopper. And I have to say, Starhopper looks better than ever with protective paint. I cannot wait till SpaceX opens this area to the public. Moving over to Pad A, it is still undergoing minor repairs following Flight 6. However, those should be wrapping up soon. Alright, back to the pad. It's been a little over 2 weeks since the last launch, and seeing as it only took SpaceX 2 weeks to repair the pad enough for a static fire after Flight 5, it should now be nearing operation any day if it hasn't already. Most of the repair work is wrapped up. Last week, teams focused on the launch mount, including the booster quick disconnect in particular. It is a similar story for the tower. All looks shiny again. Precious. The antenna at the top of the tower, possibly the reason for no catch during Flight 6, has been fixed, and very little work is still being done on the tower itself. Interestingly, we've yet to see any upgrades to the tower, and since that caused a failed booster catch, I'd be surprised if it stayed that way for much longer. Communication redundancy for the tower should be a top priority on SpaceX's to-do list. Their progress towards making this launch pad more reliable and reusable has been incredible. They've managed to reduce the repair time from a few months to just a couple of weeks between flights. Hopefully, with more advanced designs, that will be reduced to mere hours in the future, at least that is the plan. With Flight 7 now speeding towards launch readiness, it's no surprise we've begun seeing the first public filings for the launch completed. We should begin seeing more and more of these as we get closer to the launch. The first one we see is for the FCC, as licenses with them are relatively simple compared to the others. This new license also has a date from the 14th of this month to June 14th of next year. Wait, so does that mean we'll need to wait for Flight 7 for a whole 6 months? Fortunately, no. The FCC allows very wide windows in licenses. So this is likely just to simplify the overall process, as there are always 6 months between the beginning and the end of the license. But it does mention Flight 7 in particular. The most precise date is still a separate filing from before Flight 6, pointing toward January 11. With the rate that SpaceX has been moving in prototype development, it's stunning to see what else they do at the same time. How about 3 Starship launch pads? By the way, this will eventually bring SpaceX to 7 active launch pads for Falcon 9 and Starship. Can you believe it? And I have excellent news. Starship's 3rd pad is actually much further into development than you may realize. We haven't gotten a chance to cover the pad over here at the Cape often. It may be a bit surprising to some of you just how much work has actually been done already. As of now, Starship's 3rd tower is even further along than the one currently under construction at Starbase, as it's only missing its ship quick disconnect. Thanks to our amazing Cape photographer John Winkopp, we were able to get some photos on the ground to show the recent work. While it is clear that most of this is just prep work, such as raising cranes ahead of increased construction, the tower has actually already seen some work. Check this out. Along most of the joints we can see it's begun receiving similar reinforcements to those added to Tower A and B at Starbase. These are reinforcement plates intended to strengthen the towers during a catch so they don't bend and break under the extreme loads caused by grabbing the world's largest rocket booster out of mid-air. Yeah, about that. Interestingly, while the tower has received reinforcements, the chopsticks have yet to get any work done to them. In fact, they still need their actuators. Instead, they are being held together by ropes. It seems a little odd that SpaceX would implement these before anything else, which may point to a different reason for these reinforcements. Perhaps they are a necessity for the tower structure in general rather than just for the catch, and therefore need to be implemented as soon as possible? Fortunately, with all the activity on the ground, it is clear SpaceX is finally moving ahead with the East Coast Starship show. Now the real question is, should we start calling this Pad 39 AA? Starship will revolutionize the space industry whenever it becomes fully operational, and very few other vehicles will be able to compete with it. However, there may be some on the way that stand a chance. One of the few currently being developed from the ground up with full reusability in mind is Stoke Space's Nova rocket, and it's using a fascinating approach. Just like Starship, this vehicle will be fully reusable, with both of its stages landing propulsively. However, unlike Starship and some Starship copycats, its second stage re-enters engine first, with a purpose-built, actively cooled heat shield to survive re-entry. With SpaceX even considering this as an option for Starship again, it's clear that this design is at least appealing to attempt. Occasionally, these prototypes go through an update even before being built. For Starship, this has happened several times, from the ITS to the BFR and now to Starship. Stoke Space does the same, and they've now finally released their latest design for Nova. At first glance, the design appears similar to that of a Falcon 9, with a crew capsule on top. But don't be fooled, because rather than a crew capsule, this is actually the rocket's second stage. Huh? However, they intend for their first stage to be a fair bit more advanced than that of SpaceX's workhorse. So while it may look similar, it's actually peppered with differences. The most obvious one is the material choice. Stoke, similar to SpaceX, has chosen stainless steel for its rocket because of its many advantages, such as price and ease of use. Differences include reducing the number of landing legs to 3 and possibly getting rid of the grid fins. Though, getting rid of the grid fins? While this may just be an artistic choice in the renders, it is possible Stoke may decide to skip using grid fins and attempt to use other steering methods during first stage re-entry. There does appear to be an interstage near the top, similar to the interstage on Blue Origin's New Shepard rocket, which could be similarly used for steering. Interestingly, if this is an interstage, Stoke may also be going for a hot staging design, as it's clear there are vents around the edges. These vents are needed for hot staging to give the exhaust gas of the second stage a way to exit the interstage while hot staging is in progress. So far, most of the work we have seen for Nova has been focused on its second stage. That will likely be the hardest part to get right. SpaceX did the same during the early Starship SN program. However, along with these new renders, they shared something incredible. They gave us a peek inside their factory, showing that they've already started producing sections of Nova's first stage. While these are likely early pathfinders, Stoke is moving extremely fast. Its engine development has also been moving along nicely. While their second stage uses a highly unique and efficient hydrogen and oxygen-fueled engine with multiple nozzles that form what is essentially an aerospike, their first stage takes a more conventional approach. It's powered by 7 Methalox full-flow staged combustion cycle engines. Wait, where have I heard that cycle before? These engines are quite similar to SpaceX's Starship Raptor, as they utilize the same combustion cycle and fuel. However, they have quite a bit less thrust and are in a much earlier stage of development. Stoke has already shown that they are well into developing these engines, having static fired them multiple times. Haha, fire! However, it is important to note that Nova is quite a bit smaller than many other rockets we have compared it to. It has a payload capacity of only around 3,000 kilograms to LEO when being fully reused. That's in contrast to the nearly 19 tons that a Falcon 9 can lift, and far less than the 100 tons that Starship will hopefully soon be able to achieve. If Nova is successful, it can fill a niche similar to that of Rocket Lab's Electron. With full reusability, it will be able to undercut even partly reusable rockets such as Falcon 9, and its smaller size should allow it to undercut Starship for many payloads as well. It's likely that Stoke will also not stop here. They'll continue developing this technology after Nova. They are currently among very few besides SpaceX actively developing a fully reusable rocket. This moves them into a very competitive situation even without launching a rocket into space yet. While some companies aim for full reuse or at least reuse of the first stage, one is attempting to take a slightly different approach. Vulcan is ULA's latest rocket, and it's supposed to compete with SpaceX's Falcon 9. However, unlike Falcon 9, it's not reusable, meaning it costs quite a bit more to launch. However, that may be changing soon. This vehicle was never designed with the intent of full first stage reuse. However, it was designed at a time when Falcon 9 was first showing that reuse was possible, meaning they needed a plan. Enter what ULA has dubbed Smart Reuse. Instead of propulsively landing the first stage, the expensive engine section is jettisoned before deploying a heat shield and then parachuting safely down to be recovered. Wow. ULA considered Smart a good alternative, as the engines make up the majority of the first stage cost. However, the complexity of propulsively landing a full first stage was also deemed too great and would have likely delayed Vulcan's development significantly, stuck between a rock and a hard place. However, this system was always meant to be implemented later. Many wondered if it was even still in development. Now, thanks to Tori Bruno, we have a definitive answer. This is part of the inflatable heat shield ULA has been developing for Smart. In the post, he also stated that it is approaching its CDR, or Critical Design Review. This is when the design is finalized and production of the first test articles usually begins. Nice. While that means Smart Reuse is likely still a few years away, this does show that it is still being developed and may finally make Vulcan more competitive to Falcon 9. However, it's yet to be seen if this will be competitive with some of the newer rockets coming online, such as Starship and Nova. That's it for today. Remember to smash that like button, subscribe for more. This is what fuels the algorithm. This is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. A new Raptor design and our epic brand new Flight 6 design with a banana for scale are both up. The perfect Christmas gift. There is a massive sale in our merch store right now. 25% off everything and free standard shipping until December 8th. Link is in the description and in the card you should see now. Also check out our print store at shop.whataboutit.space to buy a picture for your favorite wall. A significant amount of every purchase goes directly to our photographers, and if you want to train your space IQ even further, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode. 7. January 11th, as the Russian would say. Ooh yeah. Preppered with different. It's go time! Yes!